Hello everyone, so I am back with the third video of the video series on class 9 maths number systems, and in this video we are going to learn about the real numbers and their decimal expressions. Now when I talk about real numbers, we majorly talk about the rational numbers and the irrational numbers. Okay. Now the rational numbers, as we all know, are in the form of p by q, where q is not equal to 0. Now, how are we going to convert it into decimal form? By the division method, the normal long division method. Now, we will always come across two situations. One situation could be that the remainder is 0. And in such cases, the decimal that we get is going to be a terminating decimal or a non-repeating decimal. The second situation could be that the remainder is never 0 and we see that a set of numbers keep repeating over and again. So in such cases, the decimals would be a repeating decimal or a non-terminating decimal. Whereas when I talk about an irrational number, the remainder is never 0 and there is no repetition. Therefore, we get a non-repeating, non-terminating decimal. Too much of information, right? So all confused. What is repeating? What is not repeating? So let us understand the same thing using examples. So let us take examples for each of these categories. So in the first category, let us consider this example of 7 by 8. Let us consider this rational number. Now if I convert it into decimal, what happens? So 7 by 8, so if I have to convert into decimal, so this is how it will be. So 8 is a 64, so we are left with 6. So 8 7s are 56, this is 4. 8 5s are 40. So what happens? What is the remainder that we get here? Remainder is 0. And what is the type of decimal that we get here? It is non-repeating. So the numbers or the digits are not repeating. So it is non-repeating and the remainder is 0. So this is what I meant. So if we have a rational number, so for a rational number, one possibility could be that the remainder is 0. And if the remainder is 0, in that case, the decimal expression will be non-repeating. So you will just have terminating decimal. This is what we call as terminating decimal. That means it ends, it terminates. Okay. Now let us look at the second possibility for a rational number only. So in this case, we will say that the remainder is not 0. For example, let us take the example of 10 by 3. Let us try to convert it into decimal. So 10 by 3, so 3 3s are 9. 1. So we take a decimal here. So 3 3s are 9 again. 1 again. 3 3s are 9. 1 again. 3 3s are 9. 1 again, and so on. So you see the remainder is not 0 in this case. And what is happening to the decimal expression? It will continue like this, 3.3333333 till infinity. Right? So how do we express this? We write it like this, that 10 by 3 can be written as 3.3 bar. So this dash on top shows that this particular digit 3 will continue to repeat. So what is happening? So this is a repeating decimal or non-terminating decimal, because here the decimal is not ending. It is continuing. This digit will keep coming over and again. So that could be a case. Now, it is not necessary that the same digit will keep repeating all the time. There could be another scenario where the remainder is not 0 and where the digits are repeating, but it is not just one digit which is repeating, but a string of digits which are repeating. For example, let us take 1 by 7. Okay, let's try to convert it into the decimal format. So what happens? 7 1s is 7, so we have 3. 7 4s are 28. 7 2s are 14. 7 8s are 56. 7 5s are 35. 7 7s are 49. Now again 7, 1 is a 7. So we have 3. 7, 4 is a 28. So this is going to be a very long division, but what you will notice is in this pattern, the remainder will not be 0 and this is repeating. But you see it is not just one single digit which is repeating, but the series of digit which is repeating. This entire series 1, 4, 2, 8, 5, 7 will repeat. You see 1, 4 already started coming up and now you will gradually see 2, 8, 5, 7. So it will be something like this. 0.142857, 142,857, 142,857 and so on. Clear? But both of these categories, they fall under the category of rational number. So in rational number, basically we have these two possibilities. One possibility, remainder is 0. So it is a terminating decimal or non-repeating decimal. Second possibility is remainder is not 0. In that case, it is a repeating decimal or a non-terminating decimal. So in that case, again, you could have two options. One option could be one digit keeps repeating. The other option could be that a string of digits, they keep repeating. Clear? So far, so good. Great. Now let's look at the irrational numbers. So in case of irrational numbers, we are talking about such numbers where the remainder is not 0 and also the decimals are non-repeating. For example, if I have to take examples of irrational numbers, let's see if I talk about pi. What is the value of pi? We take it as approximation as 3.14, but it is not 3.14. The actual value is 3.1415926535897 and it continues. And you do not see any kind of repetition anywhere. So it is a non-repeating decimal and also obviously since it is not ending, so it is non-terminating also, so the remainder is not 0. So non-repeating, non-terminating decimals, that means it is an irrational number. Similarly, you take any irrational number, for example, root over 2. Again, we take the value as approximately as 1.414, but actually it is 1.41421356237 and so on. And again, it continues and there is no pattern, there is no repetition. So why I told this? So now looking at the decimals only, you can tell whether the number would be a rational number or an irrational number. So if you see that it is a non-terminating, non-repeating decimal, that means it is irrational number. If it is a terminating decimal, then it is definitely rational number. If it is a non-terminating decimal, but it is a repeating decimal, in that case we will say it is a rational number. So based on this knowledge, you can easily look at a decimal number and tell whether it is rational or irrational. So it's time to look at some questions. So that's practice time. Show that 0.333333 is a rational number. Express it in the form of p by q, where p and q are integers and q not equal to 0. So first of all, just looking at the decimal format, what can we say? It is 0.3 bar because 3 is repeating. So it is a repeating decimal. So this is a rational number, because for irrational number this has to be non-repeating, non-terminating, right? But that's not the case. So this is a rational number. So we quickly answered. Now we also need to write it in the form of p by q. So how will we write it in the form of p by q? So for that we follow a very simple trick. First tell me how many digits are repeating in this case. Only one digit, that's 3. Since one digit is repeating, what we will do is, we will first say that okay, x is equal to 0.3333, so on. Now we will multiply this entire thing by 10. Why by 10? So I'll tell you why. So you will get to know that a few seconds later. But for now, you just know that whenever you have one digit repeating, you multiply it by 10. You have two digits repeating, multiply it by 100. Three digits repeating, multiply it by 1000. So that's how you have to do it. So if I multiply this entire equation by 10, it becomes 10x is equal to, so this becomes 3.3333. It continues to repeat like this, right? Now let us suppose if I subtract these two equations, as in if I subtract equation 1 from 2, so what do we get? So we get 9x, So 10x minus x will be 9x, and 3.333333 minus 0.333333 will be equal to 3, because 0.33 is like it's till infinity for both of these. So this will become 3. So x will be equal to 3 by 9, which is equal to 1 by 3. And what is x? X is basically 0.3 bar. So in terms of p by q, we have already written it. It was simple, isn't it? So now if I ask you, why did I multiply it by 10? Can you answer? Of course, because the moment I multiplied it by 10, what happened? Decimal के बाद वाला part गायब हो गया. So we got rid of this repeating part, because that was creating all the trouble for us, right? Because we don't know how many times 3 is repeating. So how do we handle that? So we managed to get rid of that part, but still managed to find out the p by q form of x. So this is the trick that we are going to follow. So let's look at one more question. Is 12.234435623459? I think it will take too much time to read the entire thing. Is this an irrational number? So what do you think? Do we see repetition? No. But do we see that it is terminating? No. So basically this is an example of a non-repeating, also non-terminating decimal. Therefore, this is an irrational number. So yes, this is an irrational number. Moving ahead to the next question. Find irrational numbers between 1 by 7 and 2 by 7. Even before I try to find that, first of all, I will convert these two numbers into their decimal expressions. And how will we do that? Simple, by division method. So 1 by 7 can be written as 0.142857 bar, because this entire string of digits keep repeating, right? And what is 2 by 7? Okay, another interesting thing. Now you do not need to divide this entire 2 by 7 thing. So if 1 by 7 is this, so 2 by 7 will be 2 times of this. So you can simply multiply this by 2. So you will get 0.28514 bar, right? So now we have these two numbers in their decimal form. Now we have to find out numbers between these two numbers. Now there will be infinite irrational numbers between these two numbers. So what we need to do? We need to find any number that is non-repeating, non-terminating between these two numbers. So you can randomly pick any number. So let us suppose if I randomly pick a number like this, say between 0.14 and 0.28. It has to lie in between these two numbers. So you can say 0.1623812459136. What is this? This is non-terminating. This is non-repeating. So this is an irrational number, and you can literally pick any number between these two, just that it should lie between 0.142 and 0.28. So it could be 0.2513694235. It could be anything. So the entire logic is that it has to lie between these two numbers, and it has to be non-repeating and non-terminating. So moving ahead with the next question, write the following in decimal form. 36 by 100. So 36 by 100 can be written as 0.36, and this is a terminating decimal. 1 by 11. So if we actually convert it into the decimal form, what do we get? We get 0.09 bar, because it keeps repeating. So this is non-terminating and repeating. 1 by 8. So this can be written as 4.125, because 1 by 8. So this is not 41 by 8. This is basically 1 by 8. So this will be 8 4s are 32 plus 1 33 by 8. So this will be written as 4.125, and that is a terminating decimal. Then we have 2 by 11. 2 by 11 can be written as 0.18. So this is also non-terminating, repeating. So in this fashion, we can write down the rational numbers in their decimal form. You know that 1 by 7 is equal to 0.142857, where this entire thing keeps repeating. Predict the decimal expansion of 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7 without doing long division. That's pretty simple. So if we know 1 by 7, how do we find 2 by 7? By multiplying it by 2. Simple. So in a similar way, if we have to write its corresponding decimal expression, we will simply multiply it by 2. So 2 by 7 will be equal to 2 multiplied by 0.142857 bar. So this becomes equal to 0.285714 bar. So in a similar way, you can find out 3 by 7, 4 by 7 and so on. And for your verification purpose, you can actually do, just to verify, I'm showing you, you can actually perform the division method to see that if this is what you get. And you will get the same thing. So let's say 0.072 is a 14, so 6, 7, 8 is a 56, 4, 7, 5 is a 35, 5, 7, 7 is a 49, 1. So you see, you are actually getting the same thing, right? So whenever you are given 1 by 7, you have to find out 2 by 3 by 4 by 5 by 7. Just multiply by 2, 3, 4, 5 or whatever number you want to. Express in form of P by Q, where P and Q are integers and Q not equal to 0. So sometime back we discussed about the trick that we are going to follow whenever we have to write a decimal, that too a repeating decimal in the form of P by Q. So let us try with all these three. So let us first try with the first one. Let us suppose X is given as 0.6666 and it keeps repeating. So how many digits are repeating here? 1. So we will multiply it by 10. So this becomes 6.6666 and so on. Now we subtract the first equation from the second equation. As a result, we get 9x is equal to 6. Therefore, x is equal to 6 by 9, which is equal to 2 by 3. And that's our answer. It's in the form of P by Q. Great. Now let us look at the second one, which is 0.47. So here we have 2 decimals after the decimal point, right? So let us first multiply. So this is x. So let us multiply it by 10x. So what do we get? 0. So we get 4.7777 and it keeps repeating. If we multiply it by 100x, what will we get? We will get 47.7777 and so on. Now, why did we multiply it by 100x as well? Because if we multiply it by 10x, now even if we subtract these two, it will not solve the purpose. So we want to subtract two such equations such that after point we just have the repeating number. But in this case, that's not happening because here it is 0.777. But in the first case, it is 0.4777. So we want to get rid of that 4 as well. Correct? So we found 10x, then we found 100x. Now if you see, if we subtract 10x and 100x, then we can get rid of this entire repeating part. So let us do that. Let us subtract 10x from 100x. So we get 90x is equal to 43. So x is equal to 43 by 90. So that's our answer, and that's in the form of P by Q, where P and Q are integer and Q not equal to 0. In the third option C, we have 0.001. So here how many repeating digits do we have? 3. So we will multiply it by 1000. So this will be 1000. So x is equal to this. So 1000x will be equal to 1.001001 and so on. So now if we subtract these two, so what do we get? We get 999x is equal to 1. Or x is equal to 1 by 999, and that's in the form of P by Q. So now the trick is pretty simple. So our whole idea is when we subtract the two equations, we should get rid of the entire repeating part. So that's the idea. Classify rational or irrational number. So looking at these numbers, we have to tell which is a rational number and which is an irrational number. So first one, root over 23. So this is not a perfect square. any square root which is not a perfect square is always an irrational number. Second option, root over 225. So this is a perfect square because 220 root over 225 is equal to 15. Therefore, this is a perfect square and therefore this is a rational number. 0.3796. So this is a terminating decimal. Therefore, this is a rational number. 7.478478 and so on. So this is non-terminating, but this is repeating because we can see that 478 keeps repeating. So therefore, this is also rational number. 1.10110001100001100001. So here we see this is also non-terminating and this is also non-repeating because none of the digit or string of digits keep repeating. The exact string of digit has to repeat. So if it has to be repeating, it has to be like this, 101, 101, 101, 101, like that. So this is non-terminating, non-repeating. Therefore, this is irrational. I hope you found the video useful. In the next video, we are going to learn about operations on real numbers. So stay tuned.